of induction motor used are squirrel cage type for our practical applications, various applications in industry, commercial, isn't it? And only one approach where you need high starting torque, we go for rotor resistance method. So that is only for slip ring, where you need high starting torque. Lifts, elevators, and escalators. They are going for the slip ring induction motor, where you needs to lift heavy loads or move heavy loads. So the slip ring is required. So they have their own advantages as a direct online starter. The first one, before we go for that particular starter, why we need starter for three-phase induction motor? What is the necessity of starter for three-phase induction motor? Why? Why starter? Okay, starter is necessary for three-phase induction motor. Necessary for three-phase induction motor. Is it self-starting or not? Three-phase induction motor. Induction three-phase induction motor is a self-starting or not?
Self-starting, sir.
It is a self-starting. Okay, but single-phase induction motor is not self-starting. You see that single-phase induction motor is not self-starting, but three-phase induction motor is self-starting. What does it means? When you switch on, it starts rotating, isn't it? No need of any extra techniques to use a capacitor or something like that. But single-phase induction motor cannot be started with one phase, single phase. We have to divide into two phases. That we have detailed study about later. Why starter is necessary for three-phase induction motor? In DC motor also we discussed why starter, 3-point and 4-point starter, why we need starter for a DC motor.
Starting,
Anybody can tell? Why
starting
starter?
current will be
Yeah.
high, sir. It is 7 times of full load, sir.
Ah, okay, good, good. So where here also in induction motor also, in induction motor also current taken by the motor will be high.
Yes, sir.
Okay. Why it takes a high current? Why it takes high current? At the time of starting, why three-phase induction motor takes high current?
It is directly connected to the supply, sir.
Okay, why it is taking, and that only starting, no? Later,
Yes,
not
sir.
required. Mainly here also, in the back EMF problem, here also the back EMF will not be produced in the beginning. Due to the absence of back EMF, the current taken by the induction motor will be 5 to 7 times more times the full load. Okay, full load current, 5 to 7 times the full load current. It is taking how many times more? 5 to 7 times. If 10 amps is its full load current, maximum current of the motor is 10 amps. How much it will take? If you don't use the starter, it will take 50 to 70 amperes. It will take 50 to 70 amps. The maximum current is 10 amps. The motor it has the capacity to take. But if you don't use the starter, it will take 50 to 70 ampere. That is 5 to 7 times. It's nothing but a 50 to 70 amperes of current. What happens if it takes such a high current? Yes, anybody can tell? What
It may
happens?
damage the motor windings, sir.
Okay, it is damaging the motor. One thing. Okay, it is damaging the motor. Fine. It is a three-phase motor like this. Okay, this is some device. This is an induction motor, three-phase induction motor. It's connected to the three-phase supply. Three-phase supply. Okay. So what happens? This current 50 to 70 amps at the time of starting, what it is taking. This current. This current, whatever the current it is taking, 50 to 70 amps, not only it is damaging the three-phase induction motor, it is affecting the see, it is operating at, let us say, 400 volts. This is also operating. There is other device, other equipment, okay, other equipments connected to the same line. Supply is same. It is also operating at 400 volts. But at the time of starting, what happens, if it is taking such a high current, 50 to 70 amps, use voltage drops appears across the induction motor, and it will not get 400 volts, it may get 300 volts. It is affecting the performance of other equipment which is connected to the same supply. This is a common supply. Anybody can take it. Any number of devices you can connect it. If it is connected to the same supply where induction motor is operating, it takes high current which will cause a huge voltage drop across the induction motor. There is a voltage shortage for the other equipments. And the performance will get affected here because they are also designed to work at 400 volts. They are not getting 400 volts. They are going to get only 300 volts, 350 volts because of use voltage drop IPSF. Okay, you might have observed in the floor mills. Okay, I visited floor mills. Floor mills. A belt will be moving, isn't it? Floor mill to grind the grains. Floor mills. Visited? Most of you visited somewhere. So what happens, when the moment they start the induction motor, the intensity of light goes down, isn't it? Because they are not getting the required voltage. That is a simple analogy I can give you here. The moment whenever you are starting the induction motor, the intensity of light goes, isn't it? The brightness of lamp goes down because they are not getting the required voltage. That is because they are also connected to the same line. The induction motor, three phase it is taking. The lamps are connected to single phase from the same source, same lines. So they are not getting the 230 volt. They may get around 200, 180 like that. Because of that, the intensity goes down. These induction motor not only damage the induction motor itself, they are affecting the operation of other equipments connected to the same line. So it is objectionable. It is not advisable to take such a high current 5 to 7 times. Okay, so how to limit then? You got a point now. Why the starter is necessary for three-phase induction motor? At the time of starting, three-phase induction motor takes 5 to 7 times the full load current. Okay, let it take such a high current. Is it producing more torque? No, it is producing only 1.5 to 2 times full load torque. It is producing only 1.5 to 2 times the full load torque. Just the torque may double, that's all. Even though it is taking such high current, it is not producing more torque. Okay, torque produced also less. It is affecting the performance of other equipments connected to the same line, isn't it? So this is the problem with the. So it's only at the time of starting because the back EMF will be zero here also. Back EMF is zero at the time of starting. Once the motor starts running, the back EMF is developed inside. That opposes the extra current taken by the induction motor. In that way, we need starter for a three-phase induction motor to protect the motor. Hello? Any doubts? To protect the motor itself. Okay. So how to start the induction motor then? If you don't do the starter, definitely it will take such a high current. We have to limit this starting current by using three methods which I already told you. The first one is direct online starter, DOL starter, star delta starter, and auto transformer starter. How this works, how it looks, and where the area of applications we'll discuss one by one now. Okay. Basically, any doubts with respect to necessity of starter for a three-phase induction motor? This is the question is there. Necessity of starter for three-phase induction motor. Explain star delta starter, or they may ask DOL starter or auto transformer starter. One question will be compulsory from this, or two questions from this. Okay. Any doubts with this?
No,
Why it
sir.
takes such a high current? This is the answer for that. Okay, now coming to that direct online starter. In order to limit such a high current, one second, just wait. Why it takes such a large current is due to the absence of back EMF. So now, hello, can you able to see this screen? Hello, Hello.
Yes,
Yes,
sir.
sir.
We can see
Yeah. What is there? What is it? Necessity of
necessity
starter
of
on three-phase induction motor, isn't it? The rotor current is directly proportional to that. You can see that the rotor current is having very low impedance. Okay, the impedance of that rotor is less, so it takes high current. Okay, it is. You can see it. One second. You can read what is there in that. So, can you able to can you able to see the cursor here? Just moving cursor. Hello. Can you able to see this cursor?
no, sir.
Cursor is not responding. So this cursor necessity of starter. Can you able to see this? Hello.
Yes, sir.
Just I highlighted. No, that you can see this. Okay now. Okay, current taken by this induction motor will be very high. That you can see this current is very large as compared to full load. Thus, a squirrel case induction directly, if it is connected, it will draw 5 to 7 times the full load current from the mains. This heavy current is may not be dangerous for the motors because it short duration. Okay, motors may not be much dangerous, but only starting turns may get damaged. But it affects the other problems what you have. It produces a large voltage drop in the distribution lines and thus affect the voltage regulation of the supply system. It will affect the sending end voltage and receiving end voltage, isn't it? Sending end voltage VS will get affected. Okay, or if they are connected at the end of the transmission line, they are affecting the receiving end voltage also because use voltage drop appears across them. What is voltage regulation in TND? You are learning, have you come across that? Voltage regulation, Vs
Yes,
minus
sir.
Vr, Vs minus Vr by Vr or something like that. What is Vs? Sending end voltage minus receiving end voltage. These two will get affected because if you connect a large induction motors, if they are connected at the end of the transmission line, they affect at the time of starting. It adversely affect the other motors and loads connected to the same lines. As I explained, no? So the same thing. Okay. Hence, it is not advisable to start a large capacity induction motor by direct switching. Rather, such motor should start by means of starting devices. Those starting devices are called starters. Okay. Starter. The function of starter is to limit the initial rush of current to a predetermined value such that it will not get affected. A starter also has some protective devices. Overload protection will be there, thermal protection will be there. If the motor gets heated up, the starter will take care of that one. It will switch off the motor. And if overload is coming on the motor, that is also taken care. Okay, as we discussed, to protect the induction motor against the overloading and all those. So the three approaches we have from stator side, how we can control the starter. One is a direct online starter, star delta starter, and auto transformer starter. Direct online starter, as the name indicates, it is connected directly from the supply mains to the induction motor. Have you seen this starter? Have you seen DOL starter? Direct online starter.
Yes, sir.
Yeah. Yes. Up to what capacity the dual starter is used for an induction motor? Up to 5 horsepower motors only. Small motors can be started using this up to 5 horsepower only, 5 HP motors only, not above that. Up to 5 HP we can use 2 3 HP motors, 4 HP motors. We can use this direct online starter. It has some limitation also. Okay. Direct online, how it looks, how many that buttons will be there on it to start and stop. I've seen it. So it looks like this, what you can see. This is the starter, what you can see, the externally. Direct online starter it is. What are the red and green buttons you can see here? The green button is for what? Starter.
Starting.
Yeah, red is for stop.
Stop.
Okay, this is the starter, direct online starter, how it looks. Okay. Internally. The internal diagram is like this. Yeah, can you go to see this?
Yes, sir.
Direct online starter internal diagram, circuit diagram it is. Okay, how it is connected? Let's explain here. You see, this is the supply. Three-phase supply is here, and from three-phase supply, the first it is given to the mains. Here, this is what you can call it as a mains, TPST or whatever that supply point. Yeah, triple pole single. The three are there, no? Isn't it? One, two, three. Okay, mains switch on the mains. We are making it on that is it. And from there, this is what you call it as a no volt coil here. This is what no volt coil. It is also called plunger. 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 It is also. And if it is a star connected, we'll have four wires: R, Y, B, and neutral. R, Y, B, and neutral wire will be there. Okay. If it is a star connected supply. If it is a delta, we can use only three terminals R, Y, B. From here, you can see R, Y, B. Let us say it is R, Y, B. They are connected to the induction motor here. This is the one. Let us say it is R, Y, B. It is a delta connected stator winding. It is R, Y, B. Here it is R phase, Y phase, and B phase. And they are connected through this overload relay as well as this plunger. No volt coil here. This is what you can say. This is the plunger. It is normally open. Okay. And these two are push buttons. What you can say, red and green buttons. What you've seen in the diagram. Okay. These buttons, red and green buttons. Here they are. These two buttons. We're getting this is point. Okay, this is
Yes,
called
sir.
no volt coil. Where this no volt coil is connected. This no volt coil is connected across any two phases. Here it is connected between here one wire is going like this, and from there and all these things it is connected to the first one. It is connected between R and B. This arrangement, no volt coil, start stop button, overload. Okay, all these things are connected between two lines. That is RYB is there, no supply point. They are connected here. This no volt coil or magnetizing coil. Okay, this is connected between R phase and B phase. Between any two phases, it is connected, but here no volt coil. With the stator winding, the three-phase supply, before it is given to the three terminals R, Y, B, there are two protected devices. The current has to pass through these two devices, plunger as well as this one. It's clear now what the internal diagram it consists of. Thermal and plunger, these two are protective devices used. And there is an induction motor. So when you switch on the supply here by closing this, and what you are doing is you are pressing the green button, isn't it? When you press the green button, so what happens here? This will get supply, and the plunger moves towards right. Normally it is open. You can see it is an open circuit. When this is moved forward, this will close this circuit. This will close this, and this will close this. The circuit get closed. Okay, when you press the button, what happens here? So here this is plunger moves towards right, and the circuit completes. Otherwise it is an open circuit. You can see here when you press that on button, so this will get magnetized because it is getting supplied directly without any this part. You can see when you switch on the mains, the first supply will be taken by this no volt coil. You can, because this is before this contact, before the open circuit, this they are connected. You can see once you close this one, still the motor is not on until you press the on button, but this will get the supply. It will get magnetized. It is pulled like this. When you pull like this, so what happened? This is circuit is closed. Now the motor is getting the supply. Now the motor is getting the supply. When you want to stop it, so what you have to press the off button here. It is normally closed. We call it as a normally closed, normally open. Normally closed, and it is normally closed. It is when you press this red button, what happens? This will not get the supply. It demagnetizes. Then again plunger moves backward, left side. Again it is disconnected from the mains. So this is the internal working how it is. And whenever excessive current flows through here, Okay, the thermal relay. What's overload relay? When overload relay, that means when the induction motor is taking more current than the predetermined, so the thermal protection is given, isn't it? This will move towards the right. This is disconnected, thereby that will not get any supply for this. Okay, thus the motor is protected against overloading also. Okay? So this is what the explanation what is given. The induction motor up to 5 HP can be started by the starter. As I told you, okay, induction motor up to 5 HP motor can be started by the starter. And automatic, nowadays what is happening now, you need not to press the button, green and red button. They are already automatic starters are available. They are all PLC based, programmable logic controller based, or microcontroller based starters are there automatically, just you can remotely operate it there. Okay, that's what almost all nowadays what we study. No, these are all the basics of starters, but we have already online starters have come here, isn't it? Automatic starters, what you call it? Automatic direct online starter. Manually, what we are studying all this is a manually. They are all they are controlled through the automatic only nowadays. A direct online starter essentially consists of normally four terminals, and there is a contactor coil, the no volt coil, or it is also called plunger. What you can see, there are two push buttons on and off, which are used to start and stop the motor. To protect the motor against overload, thermal or magnetic overload coils are connected in each phase. Okay, in each phase you can see one, two, three phases. Overload protection is given here. Extra, they get magnetized, it pushes the plunger towards right, it is open circuited and will not get any supply, again demagnetizes. To start the motor, on push button green is pressed, which energizes the no volt coil. As I told you, that to start the motor, the on push button is green button is pressed, energizes the no volt coil by connecting it across the two phases. The no volt coil pulls its plunger, as I told you, that this is called plunger. This total arrangement is, this is the shaft, and along with this arrangement, this is called plunger, in such a direction that all normally open, okay, contacts are closed and the motor connected across supply through the three contacts. The motor gets supply. The fourth contact serves as a hold on the contact which keeps the, in this diagram that fourth is not there, the neutral wire. This is not shown. To stop the motor, half push button is red button is pressed momentarily, which demagnetizes the no volt coil, opening the main contacts. When the motor is overloaded, the thermal overload relay contact connected in the control circuit, thus disconnecting the no volt coil relay from the supply. Overload protection achieved by thermal. That's what I told you, that this when it's overloaded, okay, so this is disconnected here, and the no volt coil will not get the supply. It get demagnetizes itself. That is a working. So advantages: direct online starter is almost, it is a less costly motor starter. Dual is the simplest motor starter of design and maintenance, very simple. But the starting torque is very high. Whatever the torque it develops is 100% starting torque. It is sometimes it's good and sometimes it's not required. Dual starter up to 5 motor can be used here. Okay. Disadvantages: not suitable for high rating motor. As I told you, up to 5 motor you can use. Not suitable for large capacity motors, more than 5 HP motors we cannot use this starter, the limitation. And voltage dip on the system because of high starting torque. There's high starting torque, sometimes it is required, sometimes not essential. Okay. So any doubt with respect to this DOL starter? Hello, something you understood how it works, what are the protections devices are there inside, and hello, others. If you have any doubts in this, you can ask me. Most of you seen it already. Huh? You know that in most in the laboratories, machine labs, or in other cases in the mechanical shops outside also. So, any doubts in
Excuse me,
this?
sir.
Yes, tell me.
Sir, it is not going to limit the starting current, no, sir. So
Which one?
how it is free for DOL starter?
Ah,
There is no uh, limiting elements for us, limiting this starting current, no, sir.
yeah.
Then what is the use, sir?
No. Along with the protected devices are there, no? Because already this is device is used for the lower capacity motors. Starting current is dangerous for high capacity motors. This is one of the protected devices they are using, just as a protected device. That's all. Okay. Hello. Getting my point?
Yes, sir. Got it,
I
sir.
told I told in the starting there. Here is a point. See, this heavy current may not be dangerous for the motors. Okay, but for large
Okay, sir.
capacity motors, it is dangerous, and that too, it flows for a short duration. But for normal working condition, we need the starters. For normal working conditions, we need the starter. That's why this application is limited for the lower capacity motors, not for the higher capacity. When you want to go for higher HP motor, we have to limit it definitely starting current. You have to limit the starting current. Here it is a mainly protection purpose. This is a good overload protection and all this. So then we have another approach, what you call it as a star delta starter, isn't it? That's an second method of starting the three-phase induction motor. If you want to go for higher capacity up to 20 hours power, 30 hours power, then you have to go for more than 5 HP motors. After again, that has a limitation uh, because of that low starting torque. Star delta has its own advantages and disadvantages. So the second approach is the star delta starter, isn't it? As the name indicates, why star delta is given here, you know that in star connection, what is the voltage per phase and what is the current per phase in delta. That relation, you know that star delta starter. Yes, you know that it's having some requirement. Star delta starter compulsory the induction motor should have six terminals here. Six terminals. Then that is another problem we have here. Yeah, that induction. The second method of starting what you have the star delta starter. Star delta starter. Why it's called a star delta starter? We know that in case of star connection, phase voltage equal to line voltage by root 3. That means the voltage across each phase gets reduced. If it is 400 volts by root 3, so it gets reduced to 231 volts. So when voltage gets reduced, so what happens? Even the current, starting current also gets reduced. IST is equals to starting current, ISC by root 3. Starting current. This is the starting current. Okay, SC means starting current. Okay, this is the flows if you don't use the starter. If you use the starter, it gets reduced by root 3 times. It gets reduced. The starting current. If it is a again it is a if it is a line current, so what happens here is if let us say it is a phase current, so what do you know that in delta normal running condition it is equals to what times it is line current equal phase current equal to line current by root 3, that is IL by root 3 divided by root 3, it becomes IL by 3. That means the normal working condition the current rate reduced by 3 times. Okay, so the current get reduced almost 58%. Current is reduced here. 58%, 57.7 times. The starting current reduced using the star delta starter is nearly 58%. It takes less current. And even it produces the torque, starting torque is equal to one third of full load torque, one third of TFL. Starting torque also reduced here. Okay, starting current. The advantage of star connecting them in star. Okay, and there is a provision for the winding to connect in star and delta when there will be an handle. If you move up, the winding is automatic, the stator winding is star connected, thereby voltage for each phase will be reduced to 230 volts. When voltage reduced, the current also reduced. Okay, it happens in a few seconds, all these things. By the time the current taken by the motor also, so get the normal working condition also 1 by 3 times. Line current, if we take it reduced to 58%, current is reduced at the time of starting. The torque is also reduced to equal amount, one third of full load torque. You've seen this state. I think it's star delta starter. You can see it star delta starter. So once the motor attains about 80% of speed, then the handle is moved to the delta side. When delta connected, line voltage equal to phase voltage, VL equal to V phase. Even 400 volts it is taking because already back EMF has developed. So that will take care. At the time of starting only, we have to limit the starting current for a large capacity motors, isn't it? A star delta motor is most commonly used. It's used for most of the applications. A star delta starter control the star connection. So you can see for normal working, the winding is delta connected, and for starting only a star delta starter. You can see this a star connected stator winding for starting, and for normal when motor reaches 80% its full load speed, it will begin run as a delta connected winding. There should be a provision of 6 terminals. Those 6 terminals are connected to the handle. There will be a provision. So this is the handle. What you can see this. It is a star delta starter. When the handle is moved up, you can see this star connection. It's a delta. When you move up, the windings are connected inside star. The 6 terminals are connected to this box inside this starter. When the handle is moved up, the winding is connected in star, stator winding. Thereby it takes less voltage, less starting current. When the handle is moved down, so what happens? The winding is connected in delta. No problem. This all happens in few seconds only. Move up and then bring it down. So what happens? You can see it. This there is a provision. Okay, this is the stator winding. What you can see, 1, 2, 3. This is the stator winding. Okay, which can be connected in star as well as delta. Star means when you close this. Okay, there is a two. You can consider TPDT means triple pole double throw. It is called. We can move, bring it up and bring it down. When you close here, it is connected in star. We are shorting all the terminals. See, this is for starting, but it is actually in the box what I showed in the diagram. When you move up, it is a star connected. When you bring it down, it is delta connected. But here it is in the diagram. When you move down here, it is. When you close this, these terminals are shorted. The motor winding is connected in star. Okay, and when the motor winding is connected in star, it takes only less voltage. When you move up here, so when you short 1, 2, 3 upper terminals, the winding is connected in delta, starting to finishing, starting up first, finishing up second, starting up third. It is mesh connection, delta connection. Automatically, motor is connected. The terminals are taken in such a way that it will have 6 terminals: 1, 2, 3, 4, 5, 6. Starting, finishing, starting, finishing, starting, finishing. This switch helps to connect the motor in star and delta. When you show to start, it's star connected, and when you move to delta connected. So this type of starters are useful for the motor which are built to run on delta connected winding. Delta connected winding. Okay. So time is up now. So I will continue this some mathematical analysis advantages of this one in the next class. Okay. Thank you. Right. This is information sufficient what we have. Right.